Okay, so in this video, I'm going to introduce you to vectors from like a geometric perspective. Okay, so vectors. First, if you know nothing about vectors, we need to talk about some vocabulary. So, first term is a scalar. So these are quantities that involve magnitudes represented with real numbers. So things that have a magnitude associated with them, 45 miles per hour. You can feel what 45 miles per hour means versus if I said 125 miles per hour, right? You can feel that magnitude, or 15 pounds versus 1,000 pounds. Again, they have that idea of magnitude associated with them. And then we have what's known as vector quantities. So these are quantities that involve both magnitude and direction. And a vector is a vector quantity represented with a line segment. So vectors represent both magnitude and direction. So what you see here, these are what vectors actually look like if we were to draw them out. So you can see that they've all, like, this has a much larger magnitude, right, than the other two, and then they also have a direction associated with them. So vectors, it's a pretty simple idea, but it seems a little odd maybe the first time that you encounter it if you've never seen a vector before. Okay, so let's talk about notation. So vectors use either boldface type in like a book. Obviously, I can't do boldface type since I handwrite everything. So the other way we represent vectors, which is how you will represent vectors, is by putting an arrow on top of the vector. So a vector could have like AB, it could be just like V. Vectors can be whatever, but once you see the arrow, you know it's a vector. When you have a pair of letters, so the first letter is the initial point and then the second letter is the terminal point, but you don't have to have two letters, by the way. It could just be one. And then the magnitude of a vector is represented with absolute value signs. So that doesn't mean absolute value, it means magnitude in that context. And actually, I'm a bad teacher. I already forgot my own dang notation. So I just put that there in a nice bright yellow. So, okay, so the big thing though is that you have the absolute value. Okay, so two vectors are equal if and only if they have the same direction and magnitude. That is what makes two vectors equal. And then another thing is the sum of two vectors is still a vector, which seems kind of odd, right? Because it's like, oh, it's just like arrows going in a direction. But yeah, you can add them together. And so this is like just a visual representation of kind of what they look like. And we're going to talk about how to do that now in this video and get you some sense of that. So let's talk about how to find the sum of two vectors. So way one would be that you could place the initial point of so if you have the vectors a plus b, so you could take the initial point of vector b and then place it at the terminal point of vector a. However, that is one way. The way that we're going to use more commonly is going to be this parallelogram rule. So you can place vectors a and b so that their initial points are the same. So you start them at the same spot. You'll get their magnitude and direction from that point. And then you create a parallelogram and draw a diagonal. Okay, I will show you how that works, just a quick little sketch. So just the idea behind this, I've got these two vectors a and b. So what I do is I extend them to create this parallelogram. And then from this initial point here, I extend out this vector, and that is my a plus b. Okay. So a couple of things about this. We're going to play around with this more, and you'll get really used to this by the time I'm done with this set of videos. Okay, so vector addition is commutative, so a plus b is the same as b plus a. And for every vector, there is also an opposite vector. So if you have some vector a, there's also negative a, vector a. So these are the same magnitude, just going in the opposite direction. And then also, so just something to kind of wrap your head around here, if I add a vector to its opposite vector, it's not zero, it's the zero vector. So it's still a vector. So that can kind of mess with your head. So remember, you are now in vector land, so everything has to be vectors. Now the product of a scalar and a vector is represented like this. So you have just a number times that vector, so k times vector v. So you know it's a scalar if it's just a plain old number. And when you multiply a scalar times a vector, it affects the magnitude. So the magnitude becomes whatever k was, and you should take the absolute value of that because magnitude is it shouldn't be negative. So you take k times the magnitude of vector v. So this is interesting, right? This is the absolute value of k, and then this is the magnitude of the vector. And you know this again because you've got the vector notation. And then the vector itself, it still goes in the same direction as the original vector. So I know this is kind of a lot, but you'll get used to this as you kind of go along. And so one other thing I just want to talk about, because like I said, we're going to use parallelograms to help us with the sums in this set of lessons. So we will often use properties of parallelograms to solve vector applications. So I just want to tell you 3 properties. So first of all, if you forgot what a parallelogram is, I just thought I'd tell you the definition. It's a quadrilateral where the opposite sides are parallel, right? Because in math, sometimes we aren't the most creative, so it's a parallelogram. Okay, so the opposite sides and angles are equal, and the adjacent sides and angles are supplementary. This is actually pretty important when you're working with vectors and you're trying to figure things out. So you might not know why this is helpful, but I'm going to show you why in just a few minutes. And then also just one other thing to note. The diagonals bisect each other. So the diagonals, so these bisect each other, so they go through the middle, but they don't necessarily bisect the angles. So they bisect the actual diagonal lines, but not the angles. So just something to keep in mind. Okay, so let's just do a couple of basic vector problems just to kind of get you warmed up, and then I have some other videos on applications. So for each pair of vectors, the angle theta and the angle theta between them sketch the result. Okay, so I'm just going to give you some information. I've got the magnitude of 2 vectors, u and v, and then I've got the angle theta. Okay, so what you're going to do is, so the magnitude of u is smaller than the magnitude of v. So you're kind of eyeballing this, but it should make sense, right? So this should be maybe about less, a little over half of the length of this one, right? If you just think about the magnitudes. And the angle between them is 25 degrees. So that's it. Just trying to get you used to like, how do you take in this information and how do you work with vectors? So just, we're doing total basics here. Okay, now, if I wanted to find the resultant vector, so this is now sketching the result. So I first draw this picture, and now I create this parallelogram. So you see how I've kind of extended, like with these dotted lines, the sides, and they're parallel to their opposite side. So now from here, I just go from this initial point to the edge of that parallelogram. Boom, we've got the result. Okay, so I've got another one here. So, you know what? I think you should pause the video. You know what I say, math is not a spectator sport. You pause here, you try it, you hit play when you're ready. Okay, so u is literally half of v, so try to just have that represented in your vectors. And then also, so your theta, so this should be like a 30-degree angle. Again, you're just kind of eyeballing it here. If you have like a protractor, or if you really want to like, you know, use a ruler or something and get super exact, that's good. I'm just going to kind of draw sketches, and then I can just extend these sides, you know, make them parallel. And so then there's going to be my u plus v vector. Okay, and so I think we've got it. Okay, cool. So let's just talk now about another way we could think about this. So remember, vectors and magnitude kind of go hand in hand. So I have some application videos where a lot of times we will be talking about things that have magnitude. So I've got these resultant forces, 85 pounds and 100 pounds, and the angle between them is 50 degrees. So I want to know, what is the resultant force for the 2 forces? So if I have these 2 forces acting on one another, what can I say about kind of like when they're combined? Okay, so we've got this parallelogram situation. So let's call this side u, let's call this side v, so I can figure out what this u plus v is. Now here's the thing that this problem is asking for. You've got numbers here. This is 85 pounds, this is 100 pounds, we know the magnitude. Now what I want to do is I want to figure out what is the numerical value of u plus v. All right, so to do this, we're going to have to now take in some information I gave you earlier. So if this angle here is 50 degrees, then a property of the parallelogram will be that this other angle here can be found by taking 180 minus that first angle that we had. So this angle here now I know is 130. So that's something I mentioned earlier. So this angle is 130, this angle is 130, this angle is going to be 50 degrees. Okay, cool. So now what? I want to figure out what is this length here. Well, we're going to use the law of cosines to do this. So we spent all that time talking about law of cosines, and actually, like, you might not see it, your brain might not be catching on it, but actually the law of cosines will work perfectly here. So just to remind you, law of cosines, so this is for the situations when we know a side angle and a side, or side, side, side. We will see that we have that information in a moment. Okay, so you want to make sure you're looking at your parallelogram correct. So if this side is 85, this side is also 85. If this side is 100, this side is also 100, okay? All right, and so this triangle here, like half of the parallelogram, this is what we're going to use. And so I just want you to notice that we have then side, angle, side. So that criteria is met, so we can use the law of cosines. And so then remember how we actually use the law of cosines. So I want to figure out what is this length. So what is the magnitude of this? So this side squared, the one I want to figure out, is going to be equal to these two sides squared minus 2 times these two sides times cosine of this angle. Oops, cosine of this angle. And okay, yeah, so now I've got everything that I need, right? So I can figure this out. So I can go through and just, do the algebra, and so I get 167.79. So yeah, so you're going to be creating, from your parallelograms, different triangles, and so then you can use the information with like the law of cosines. And so I have other application videos where I give you different types of information and just different approaches to it. So check those out if you want to work a little bit more with vectors. And otherwise, that's it for this one, guys. So thanks a lot for watching, and I will catch you in another video.